Computers at your grocery store determines the price of each item by searching a long list of ordered pairs in which the first coordinate is the universal product code while the second coordinate is the price of each item with that code. For each product code, there is a unique price of each item. That is why if you are buying more items of the same product, the price remains the same. This process illustrates the application of function and relation to real life. But what is the difference between the two? Just stick around, for in this video, we will be discussing relation versus function. This video also contains varied ways in determining the relation or a function. That is by mapping, correspondence, table of values and graph, and rule method. If you are new to this channel, kindly hit the subscribe button and the notification bell, and I promise that I will journey with you in learning math lessons and concepts in an easy way. Relation versus function. These are the objectives. After watching this video, you will be able to illustrate a relation and a function, verifies if a given relation is a function, and determines dependent and independent variables. Now suppose we have these coordinates in the Cartesian plane. We have -4 and 0, -2 and +3. We have -3 and -4, 0 and -1. We have 1 and +3. We have +4 and -2. And we have +4 and -5. So if you put these coordinates together in a set, which means that the element of our set are ordered pair, this will make the relation. So relation is the set of ordered pairs, and this is the association of domain and range. Now in this set of ordered pair, the domain are -4, -3, -2, 0, 1, and 4. These are the set of all first coordinate or the so-called x-coordinate. While the range, -5, -4, -2, -1, 0, and 3, these are the set of all second coordinate or the y-coordinates. We have three different correspondence in relation. First, we have the one-to-one correspondence. The first set, this is the domain, and we have the range. Suppose we have a number 1 here, and this is correspond to a number 8 on the range. Number 2 correspond to 9, 3 correspond to 10, 4 correspond to 11, and lastly 5 correspond to 12. So one member of the domain correspond to one member of the range. So this is one-to-one correspondence. There are instances that one domain corresponds to many elements on the range. So we can also call our domain as the x-coordinate and the range as the y-coordinate. So suppose our x is 1, so our y is 8. It could be that our y is equal to 9. So one value of the x corresponds to two values of the range, which is 8 and 9 respectively. 3 corresponds to 10 on the range. Then we have value of 5. It corresponds to the value of 11 and 12. So in this case, this correspondence is called one to many. One value of x corresponds to two or more values of y. Last correspondence is the many to one. We can also call the domain as the input, and the resulting value of y is the output. Suppose we have value of 1 here, and it corresponds to the value of 8. We also have another value 2 here, and also correspond to the value of 8. So we have 3 correspond to the value of 10, and we have 4 correspond to the value of 12. 5 also corresponds to the value of 12. So in this case, we have 2 inputs, and we have only 1 output. So in these 3 correspondence, the first one is considered as the function. Is also considered as a function. Among these 3 correspondence, only one to many is not a function. Then what is a function? Function is a special type of relation. So therefore, function is always a relation, but relation is not always a function. So as an ordered pair, function, it is a set of ordered pair of real numbers such that no two ordered pairs have the same first coordinate, which is the x, and have different second coordinates, the y. So let's have an example. Determine whether each relation is a function. So for the first relation, 1 and 2, the elements are 1 and 2, 1 and 5, 3 and 7. So this is 1 to many. And based from the illustration in the previous slide, 1 to many is not a function. Why is it 1 to many? Because we have the same x coordinate, which is 1, and it corresponds to different values of y, the 2 and 5. So thus, this relation is considered as 1 to many. Hence, this relation is not a function. For the second relation, 4 and 5, 3 and 5, 2 and 6, 1 and 7. So in these first two coordinates, different value of x correspond to the same value of y. So this correspondence is called many to 1. And many to 1 correspondence is a function. Lastly, we have 4 and 5, negative 1 and 2, 6 and 6. As you can see, this correspondence is 1 to 1, and 1 to 1 is also a function. Now, the idea of a function can be best illustrated by this machine. So this machine is a function, and whatever you put here will be our input. And the input is the independent variable. Why is it independent variable? Because you can always choose what you are going to put here. So this is the output, and your output depends on your input. So if you put a slice of meat here, the output must be a ground meat. If you put a coffee bean here, the output must be a coffee granules. If you put a rice here, the output must be a ground rice. If you put that into quantity, or the x would be our independent variable, and our y would be our dependent variable. And this is the input and the output respectively. Function as an equation. So for example, we are asked to determine whether the relation is a function. Suppose we have a relation x is equal to y squared, and we are asked to find if this relation is a function. Also, we have y equals to x, and we have x equals absolute value of y. Now, for the first relation, x equals y squared, is it possible to find two ordered pairs with the same first coordinate and different second coordinate that satisfies the equation x equals y squared? So, since in this case, 1 and 1 and 1 and negative 1 both satisfies x is equal to y squared, that would mean that if our y is 1, 1 squared is positive 1. If our y is negative 1, negative 1 squared means negative 1 times negative 1 is also positive 1. So these two coordinates both satisfy the equation x equals y squared. So as you can see, in this ordered pair, we have the same x coordinate or input, and they have different output or the y coordinate. So in this case, this relation is not a function because this is 1 to many correspondence. For the second function, for the second equation, y equals 2x. So the equation y equals 2x indicates that the y coordinate is always twice the x coordinate. Ordered pairs such as 0, 0, 2, 4, 3, 6 satisfy the equation y equals 2x. So if x is equal to 0, so 2 times 0 is 0, so this is the ordered pair. If x is equal to 2, so this would be 2 times 2, y is 4, so this would be the ordered pair. If x is 3, 3 times 2 is 6, this would be the ordered pair. All these three ordered pairs satisfies the equation y equals 2x. as you can see, the correspondence is 1 to 1, and it is not possible to find two ordered pairs with the same first coordinate and different second coordinate. So therefore, this relation is a function. For the third equation, x is equal to the absolute value of y. So the equation x equals the absolute value of y satisfied by an ordered pair such that 2 and 2 and 2 and negative 2. Why? Because if y is equal to 2, the absolute value of 2 is positive 2. If y is equal to negative 2, the absolute value of negative 2 is also positive 2. And both are correct. So in this case, as you can see, this is one to many and this relation is not a function. Now suppose we have the relation y equals x squared. How do we graph it? What are the alternative way in determining if the graph of the relation is a function? So in graphing an equation or a function, we will make use of the table of values. In table of values, the first column, these are the inputs or the independent variable, and our second column are the output, which is y or the function of x. In our independent variable, we can assign any values of x. However, our output depends on what is the input. Suppose we have our x as negative 3. If you plug in negative 3 here, so negative 3 squared, this is negative 3 times negative 3, the value of y is positive 9. If it is negative 2, so negative 2 squared, negative 2 times negative 2, positive 4, and negative 1 times negative 1 is positive 1. This is 0, so 0 times 0 is 0. If it is positive 1 times positive 1 is also positive 1. 2 times 2 is 4, 3 times 3 is 9. So if you put this one into an ordered pair and put them in the set, this is our relations containing the set of ordered pairs. If we plot them in the Cartesian plane, negative 3 and 9, so this would be here, negative 2 and positive 4, negative 1 and positive 1, 0, 0 at the origin, then 1 and positive 1, 2 and positive 4, 3 and positive 9. Connect these coordinates. So this is the graph of the equation y equals x squared. As you can see, this relation is many to 1. Why is it many to 1? Because if we try to take a look this coordinate, negative 3 and 9, and we also have positive 3 and 9 here, we have two values of x and we have the same value of y. So hence, this correspondence is many to 1. A many to 1 correspondence is a function. Now, suppose the graph of the relation is given. How to determine if it is a function? We can do it through a vertical line test. So, what is the role of a vertical line in determining that the graph of the relation is a function? So, a graph is a graph of a function if and only if there is no vertical line that crosses the graph more than once. So let's try to have this example. Which of these graphs is a graph of a function? First graph, second, third, and fourth. So this is our vertical line. So the vertical line passes only once here. In this case, passes twice, the bottom and below. In this graph, it passes only the graph once. And in this graph, the absolute value graph, it passes the graph at 2 points. So in this case, the first graph is a function. Wherever we draw a vertical line test, it will only crosses the graph of the relation once. On the second, this is not a function because if we draw a vertical line, it will crosses the graph of the relation twice. Third is also a function, and fourth is not a function. Vertical line cross the graph of the relation twice. Relation or a function. So let us recall again that domain is the set of all first coordinate or the x coordinate of an ordered pair, and the range are the set of all second coordinate or the y coordinates. So we are asked to identify the domain and range of each relation. So first, again, we have this relation 2, 5, 2, 7, 4, and 3. So y equals 2x. And thirdly, we have y equals square root of x minus 1. So for the first relation, the domain is the set of the x coordinate or the input. So the elements are 2 and 3. For the range, 3, 5, and 7. For the second function, y equals 2x. Since any real number can be used in place of x in the equation y equals 2x, so the domain is any real number from negative infinity to positive infinity. So this notation is written in an interval form. And also, since any real number can be used in place of y in y equals 2x, the range also is from negative infinity up to positive infinity. So this is the lower boundary and the upper boundary. If you write this interval notation in the roll method, for the domain, it will be stated as x such that x is an element of real number. And the range, y such that y is also an element of a real number. Example number 3, y equals square root of x minus 1. So since the square root of a negative number is not a real number, we must have the expression inside the radical sign to be positive. To write this mathematically, this expression should be greater than or equal to 0. So greater than or equal to 0, these are positive numbers. And if you solve this inequality, this is the simplest form of this inequality. The allowable value of x so that the value of y would be a real number, these are on the interval provided x is greater than or equal to 1. Writing it in an interval notation, so this is close, 1, comma, open, positive, infinity. That would mean from positive 1 going to positive infinity. So since the square of a non-negative number is a non-negative real number also, we must have y to be greater than or equal to 0. So that would mean our y also is a positive number. So the range is on the interval close 0 to positive infinity. That would mean including the 0 going to positive infinity. In the rule method, the domain is x such that x is greater than or equal to 1 and the range is y such that y is greater than or equal to 0.
Thank you for finishing this video. If you learned something new today, kindly smash that like button. And in the comment section, kindly send me your thoughts about this video. Please don't forget to subscribe and share this video so that I will be able to continue to journey with you in learning math lessons in an easy way. See you in our next video. Thank you for watching.